All right, 7th graders, lesson 83, powers of 10, and multiplying numbers in scientific notation. A few reviews. 10 to the third really means 10 times 10 times 10. The 3 up here means I need 3 tens. So if I had 10 to the fifth, that would mean 10 times 10 times 10 times 10 times 10. Again, 5 up here, so 5 tens over here. Now, let's put those two rules together. And let's say I wanted to add these two numbers. So I say 10 to the third times 10 to the fifth. Well, what I'm really doing is I'm putting the 10, 10, and 10, and 10, 10, 10, 10, and the fifth 10 all together. I'm combining those, so I'll have 6, 7, 8, 10. Oops, sorry, 8 tens right in a row. So I should have 10 to the 8th power. So even though we're multiplying here, we add the exponents up there. So what we're going to do with those exponents is actually add them. Even though we see multiplication here, by multiplying we're just putting them all in a group. It's really what we're doing when we multiply. Put them all in a group. I got 8 of them down here. So 10 to the third plus times 10 to the fifth will equal 10 to the 8th. Okay, and again, we remember that because we're multiplying by all those zeros. We're asking how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8 zeros. So we want an 8 up here. Okay, so that's a review of multiplying by powers of 10. Now what happens if we put these and use them in scientific notation? So we get 1.2 times 10 to the fifth power, and I'm going to put that in parentheses, and then I'm going to multiply it by 3 times 10 to the 7th. Put that in the parentheses. Well, what we do first is we can multiply the two whole numbers. 3 times 1.2. Put that in your calculator, or you can imagine the 1.2 without a decimal. That's 12. It would be 36. However, I need that decimal in there. Times 10, because both of these are 10, so that's why I can do this. If one of them was a 9 and the other is 10, I couldn't do this. But because they're both 10s, I can say times 10. Now, what I need to do is I need to take my two exponents, which are 5 and 7, and add them. And I'll get over here, I'm going to get a 12. So that's my answer, 3.6 times 10 to the 12th. Okay. Now, something else I want you to notice before we go on is, here's this number. We always need to only have one number in front of the decimal, but we must have a whole number in front of the decimal. I can't have a 0 there. I couldn't have something like 0.6, oops, 0.6, and I couldn't have 12.0. I can only have one number in front of the decimal place. That's important as we move on to the next ones. So in example 2, I have 4 times 10 to the 6th. And again, that's in parentheses, and I'm going to multiply it by 3 times 10 to the 5th. So again, I'm going to take my two whole numbers, 4 and 3, and I'm going to be 12. I'm going to multiply it by 10 because these are both 10s. And then I add the 5 and the 6 to get an 11. Now, this can't be my final answer because I don't have a decimal here between the 1 and the 2. So here's where we're going to use the rules that we used before. I am going to move the decimal, which is right here. It's an imaginary decimal, and move it right over here. So I'll have 1.2 times 10. And now what's important is that exponent. Well, I moved the decimal that way, right? So if you remember that rule, then this arrow also has to go that way, and it says to go up. So again, it's like looking at a thermometer scale. Here's 0, here's a -5, here's a +5, here's a +10. We were at 11, and it says to go up, and I moved it one place, so I'm going to go up one number, and up one number would be 12. So I can put a 12 there. 1.2 times 10 to the 12th power. So the key is not to forget after you get this done. You get excited because you were successful and you got this done. Don't get too excited and forget you've got to move the decimal. All right, example 3. 2 times 10, and here we get a negative. Okay, and the rules are exactly the same as when we add and subtract negative numbers. So up here I'll get 3 times 10 to the -7th, parenthesis there. Okay. Now again, I'm going to multiply these two whole numbers. 3 times 2 is 6. I'm going to say these are both 10, so I'm going to say times 10. Now I get a -5 plus a -7. Not minus a -7, but plus a -7. And that's going to equal a -12. So my answer will be 6 times 10 to the -12th. Again, here there's an imaginary decimal, but I've got one number in front of the decimal, and it's not a 0, so I'm perfect. I don't need to change my exponent. I can leave it right there. Okay. The main thing here is not to get worried about negatives. Just do this math problem exactly the way that we've always been told. It's not going to change all of a sudden. Okay, now what happens if we combine the last two rules that we just learned? Let's see. I get 5 times 10 to the 3rd power, kind of a messy 3 there, times 7 times 10 to the -8th power. All right. Well, let's do what we've always done here. And first take the 5 and the 7 and multiply them. That'll be 35. So you can see already I've got a number. I'm going to have to move a decimal. Times 10, because these are both 10s. And then my exponent is going to be, I can write that over here, 3 plus a -8. And that's going to equal a -5. So my exponent will be a -5. Now again over here, we've got our thermometer. And over here we see I'm going to have to move the decimal one place this way to get it right here. So I'm going to rewrite it as 3.5 times 10. And again, I moved my decimal this way. So I'm going to move this number up one. Those arrows both have to go away. So I was at a -5 and I need to go up. And it says to go up only one because I only moved it one decimal place. So if I go up one place, I'm at -4. So my answer is 3.5 times 10 to the -4th. So you can see in this problem, they combined two things. They combined us having an exponent with a negative and a whole number in front in which we had to move the decimal to get to our final answer. So that the 35 changed to a 3.5 and the -5 changed to a -4. If you have any questions, don't be afraid to ask, but you can get started on your practice set then, 7th graders.